Hello, everybody. Unfortunately, I will have to turn off the screen because it's interfering with the slide presentation. So I will begin by the structure of the presentation. I will review two ways in which AP and AP-allied work has influenced or found their ways into models of grammar. I will be giving some perspective on the relation between mainstream phonological theory and AP as it has evolved over the last 35 to 40 years now. And I will end with some new results on the mapping between phonemic representation and vocal tract action. Let us begin by saying that a theory of grammar is specified when you have a theory of representations and a theory of what you do to these representations. If this is so, then there is two ways AP thinking can play along with phonological theory. Way one is dynamics and representations. In other words, build grammars on top of dynamically defined representations, keep your rules and constraints the same way as you had them before. And way two is to push dynamics into rules or constraints, or in particular to let dynamical principles enter into how rules apply or how constraint optimization is done. Let us discuss dynamics and representations first. This is the way one. So the form of the argument here, we identify facts which reveal the morphophonological relevance of distinct temporal relations between the units of AP, language-specific preferences of non-overlapped versus overlapped timing relations, assimilation in the overlap versus the non-overlapped timing relation, and so on. If we can identify such facts, then we can infer that principles or constraints in the grammar must refer to temporal relations between the units of AP. Or in other words, put in more broad terms, we can infer that our grammars are grammars of spatio-temporal form. Let me give an example. This comes from the morphophonology of Moroccan colloquial Arabic. What is shown on the left is the coordination of two identical consonants T, which is followed by T within a template, within a morphological template for the plural. It can be seen there that these two consonants are produced by what is known as an open transition. In other words, first T is released and then the second T is formed. Whereas if we look across the stem suffix juncture, as it can be seen here, this bid is the stem, to is the suffix. You can see that the temporal relation between D and T here is not the same as the temporal relation here. In other words, here you get a continuous tongue tip constriction throughout the DT cluster. I chose D here, not because we cannot find stems that end in T, but rather because I wanted to show that the first part of the cluster here is actually voiced. And this is never the case for the lexical geminates of the language. In other words, this is what is known in phonological theory as a fake geminate. And it is one piece of evidence that what we see here is an overlap of two distinct units as opposed to one homogeneous type of unit. Okay, so these generalizations apply regardless of the voicing of the D's and T's. So we have two different coordination relations, but let me show you also what happens in heterorganic types of clusters. So here the pattern is also very clear. What you get here is the gesture of a B, here's a gesture of a D, and here's the opposite type of order, first the D, then the B. In any case, what we find is that the activation windows of the two gestures are overlapping in time. This is shown also here in the box representation and also here, but it is always the case, and by that I mean it is always the case that the release of the first gesture, it takes place before the target of the second gesture is achieved. So you also get an open transition here. So in other words, you get two distinct coordination schemes, the one on top and then the one in the bottom. And the crucial observation, originally due to Lewis, in fact, is that the acoustic output T release T must involve the top coordination relation, the one with a doubled arrow, okay, the one where the boxes are farther apart from one another. It cannot involve the bottom coordination relation. If we were to plug two T's in the bottom coordination relation, then the acoustic output will be a long T. It will not be a T release T. This connects back to work by Kathy Broman on the necessity of controlling releases. We can build a coordination grammar of CC sequences in the language. And the gist of the argument is that even though this relation is attested, this is the relation that I showed two slides ago, it can be shown that this relation is actively avoided within templates, within the morphological class of the templates in this language. And this avoidance is manifested through effects that show consistent deviance from a phonological norm, just in case when following otherwise normal procedures for how segments are mapped into templates, this dispreferred temporal relation will be invoked. For example, avoidance of splitting geminates, just in case in the output we will need to invoke this relation, or glide anaptexes, just in case in the output we will need to invoke this relation, and so on. Let me just illustrate with a couple of examples. Here is a stem, it has a geminate, it maps to the plural template, and you get splitting of the geminate. And so here, for a verb, both in the nominal and the verbal type of morphology, you get the geminate splitting in the passive participle here, in the plural here. So this is the prototypical case for non-concatenative morphophonology. You get splitting of the geminates when you map to a template, but notice that you cannot split the geminate here and also here, just in case the coordination relation you would need to invoke is the C=ROC type of relation. It's clear what's going on, I hope. In standard phonological representations, the only notion of temporal is the trivial left to right sequencing of the segments. This notion is, of course, relevant for phonological theory, but it is insufficient because it collapses the distinction between the two distinct coordination relations that we have here. And the crux of the argument, of course, is to show that such differences in coordination relations have phonological results. In MCA, for example, you get different ways to satisfy your template depending on the composition of the segments. In Passil-Heat Berber, you get a voicing assimilation in the overlapped pattern, but not in the non-overlapped one. These are just two examples. I will skip this slide. I believe we know now much more about how coordination relationships are fleshed out, about the generalizability of these and the flexibility of these relations across different clusters. This is from an NLT paper published in 2019 by me and my collaborators. Instead, I would like to turn briefly to some variants of way one. So another way to pursue way one, this is the dynamics and representations way, is by showing that the mapping between phonological constructs such as syllables or feet and speech production events is elucidated when these things are fleshed out in terms of AP concepts. And there is a long and productive line of work here by Kathy Broman and Louis Goldstein, Danny Bird, Elliot Saltzman, Hossam Nam, Mariana Pouplier, Stefania Marin, Khalil Iskarus, Jason Shaw, Anne Hermes and her collaborators. And I hope that the prosody in AP talk has provided many other ways in which the statement which is given here can be pursued and has elucidated the relation between linguistic structure and speech production events. Let me turn instead to way two, dynamics in rules or constraints. So the form of the argument here is more involved. It's a more, and it's also non-unique. So the idea here is to find a phenomena which undercut the derivational relation between phonology and phonetics. Why do we want to do this? Because such phenomena require mixing discrete and continuous. And hence, as a result of that, the space of the formalism that can be used to account for the data shrinks down to basically nonlinear dynamics. There's a sequence of attempts to do so. So, for example, one type of attempt is to scale rate and expect to find qualitative effects in the phonological and the phonetic output. So for example, intrusion of gestures as we scale rate. This is the speech error paper result by Louis Goldstein and his collaborators. There is a very nice paper by Ben Parrell on Western Andalusian Spanish aspiration. Earlier arguments for this sort were more conceptual. So the early arguments by Broman and Goldstein here were along the lines of questioning the general architecture of the grammar, so the fact that the phonetics has to come after phonology, and phonology is continuous and phonetics, phonology is discrete and phonetics is continuous. So question such organizational principles of grammars by finding properties that are hallmarks of complex systems. And as a result of that, the formal frameworks that we can use have to be formal frameworks that have been applied to complex systems. So basically using nonlinear dynamics. And I said that the argument is not unique here. So yet another way is to convince the linguist that, for example, reaction times are a valid or are as valid evidence for linguistic theory as are well-formedness judgments for phonological form. Why is this an argument again for nonlinear dynamics? Because if we have reaction times, or we have to pay attention to reaction times, and we also have to pay attention, let's say, to format values or to VOTs, then we need a theory that makes prediction both about the evolution of the representations and also about the format values and the VOT values of these representations. And the only theory on the table, as far as I know, that can do that is nonlinear dynamics, or the only framework that can do that is a framework that incorporates nonlinear dynamics. And of course, this is part of the articulatory phonology toolbox. As examples of that, you can consult the work by Kevin Roon, his NYU PhD dissertation, and also Andris Quetz's work from UMass. It's another PhD thesis that uses reaction time results and tries to combine that with a grammar. So I will give my favorite example of this. This is incompleteness of neutralization. As you know, many languages have domain final devoicing. The prototypical example is coming from German, so the stem is rad, but when it's in word final position, it appears as rat. So you get rad, you lose the voicing of the final D of the stem. Instead, if we have this other stem, this is a stem for advice. The first stem is the stem for wheel. So you get, throughout the surface representation, you get a voiceless T. In terms of analysis, we have rule-based analysis in the 60s, where we take an obstruent and we devoice it at the end of the domain. Or in the 90s, we can use optimality theoretic types of analysis, where the markedness constraints prevents the expression of certain contrasts in certain prosodic or other morphological types of domains. So here you have the markedness constraint outranking the faithfulness constraint. In this phenomenon, however, what we find is that the T that comes from rad and the T that comes from rad are actually phonetically distinct. So in other words, this is slightly different from the T that we find here. And in particular, the communicative context is of importance. So for example, when you set up an experimental task where the speaker has to convey the distinction between rad and rad, so you say, ich habe rad gesagt, nicht rad, or you change the order of the words, what we find as a result of this, in particular what Bob Port and Penny Crawford found in a really nice paper in '89 in the Journal of Phonetics, you get that phonetically the distinction between the two T's is enhanced. Why is this a problem for the derivational view? Remember, this is what we want to get. We want to find phenomena that are, of course, systematic, and they present a problem for the derivational view of the relationship between phonetics and phonology. That's because we have the application of a phonological rule, which seems to be conditioned by environmental parameters. So, for example, whether you have a listener that is present in the room, when you have a listener who is present in the room, remember you get enhancement of the degree of incompleteness of the neutralization. And this is not how rules are supposed to apply, or this is not how grammars are supposed to work. There's supposed to be this very strict separation between the environment and the computation up here. So let us throw some models on the story so we can use the variable rules approach that has dominated sociolinguistic variation studies. So here you have a rule. This is your standard phonological rule from SPE, and we attach a probability of the application of the rule given a certain context. We do a logistic regression on the conditioning alternatives. We remain agnostic as to the underlying probability distribution, but as I said, this was and perhaps is still one of the approaches that has been used to account for variability in sociolinguistics. Another approach is to use optimality theory, of course, and it's more flexible stochastic evaluation type of approach from Boersma-Hayes. So here you have two constraints. Here's the ranking that will give you neutralization, and we can flip the ranking. So sometimes we gain neutralization and sometimes we don't. And the problem is that none of these are appropriate for the variability in our example. We don't have a T versus a D case, so it's not a case of one versus another category. And perhaps this is the more interesting failure of these types of approaches. There is no handle on adapting continuously to the context. So in other words, on modulating the degree of incompleteness of utilization on the basis of environmental parameters, like whether a listener is present in the room or not. So what we find is that linguistic behavior is at once lawful and flexible. And so we can ask, what is the nature of the computational principles and the representations which enable this lawful behavior? But with the flexibility that's characteristic of natural cognition. In other words, of the behavior that we actually observe. So here's a broad sketch of the analysis of this example. What we do is that we map the grammar constraint in particular linguistic system that has a rule of final devoicing, encode be voiceless, to a system of this nature. This is a space of all possible parameter values from less voicing to more voicing, and we map the force or the constraint as a force that constrains the values of the behavioral parameter that corresponds to voicing to a particular region of the space for the voicing values. So here is the voiceless region right here. And then we have intentions. Intentions can be either to produce a stem that has a voice T or a voiceless T. So intentions are mutually exclusive, and they set up an attractor at either end of the continuum. So here's the voiced, the attractor for the voiced, and here's the attractor for the voiceless. And now we join the two, and by the way, this is the simplest thing we can do. We can take the linear superposition of the markedness and the lexical force, and we let them interact. And the claim is that the interplay between these individual dynamical systems will result in the phenomenon of incomplete neutralization. Here's an example of the interaction, and perhaps this is the interesting case where the markedness and the lexical forces are in conflict. Okay, so we get the intention to produce a voice D. So you can see that the attractor now is on the left side of the x-axis, and we have the grammatical force, which requires that you be voiceless. So the two forces are in conflict here, and as a result of that, you get a blend in the output. As the weight of the lexical force in particular is scaled, so it's slightly varied, you get more or less remnant voicing is predicted due to the continuous drift of the voiceless attractor. And as a result of that, effectively, you get incomplete neutralization. So the degree of devoicing reduces as you increase the strength of the lexical force. So what are the main aspects of the analysis? This analysis maintains the discreteness of the symbolic approach while embedding it in a continuous realm. Where is the discreteness? It's in the presence of the distinct forces. We have a markedness force and we have a lexical representation, and in the attractors of the dynamical systems that define these two types of forces. But what is crucially distinct from the symbolic type of approach is that these attractors are embedded in a continuous space, in continuous dimensions, and hence these attractors can be flexibly and subtly modulated by the communicative context. Let me turn to giving some perspective here on the relation between other phonological approaches and AP. Stabilization to dynamically evolving representations is, as I just illustrated in this example, is also implicated in the gradient symbolic computational theory of Smolensky, Goldrick, and Mattis. And in previous stages of phonological theory development, for example, autosegmentalism, we find ideas shared across AP and mainstream phonological theory. So for example, if you look at the PhD thesis of Greg Lamontan, of Jay Paget, or if you look at the work by Styriade, this was the case during the development of autosegmentalism, or during the active years of autosegmentalism. And so is the case now. So in other words, there is points of contact where AP or AP-inspired work can incorporate OT insights. And in turn, AP concepts and empirical concerns from AP can inform OT. But let me back up for a sec. So for about 35 years, so mid-80s to now, AP has coexisted with mainstream phonological theory as well with shifts in the paradigm. So for example, with the emergence of OT. During the 80s and the 90s, the experimentally committed paradigm of AP sometimes produced data that had in many cases never been examined before. So back then, it was not straightforward to compare AP and or synthesize AP insights with other theoretical frameworks. Of course, there are some notable exceptions. There is a wonderful critique on assimilation in feature geometry in AP by Nick Clements. There is a critique of how the notion of natural class sits in AP by Peter Ladevogt. There is Don Castoriadis' work on metathesis. This is not a critique, this is actually an application of AP from a mainstream phonologist, allow me to call Don Castoriadis at this point, on metathesis in Romance. So what is actually different now from the times of AP autosegmental coexistence? So what differs now is that the nature or range of data seen as related to phonological theorizing has been approaching that of data which is considered relevant to the furthering of AP. So for example, if you look at the paper by Smolensky, Goldrick, and Mattis, they address two phenomena. One is incomplete neutralization and the other is speech errors. And of course, both of these phenomena have been areas where AP or AP-inspired work has been carried out on. Let me turn to something a bit more surprising about the coexistence of OT and AP. The new wave of phonological theorizing, which was based on expanded empirical, which is based, excuse me, on expanded empirical domains, has helped to bring back to light long-standing problems. So, for example, consider Fleming's OT approach to co-articulation. This is a phonology paper, appeared in 2001, one of the main papers that Ed Fleming has put out on his approach, which eliminates the distinction between co-articulation and assimilation. In contrast, if you read, for example, Carol Fowler's view on assimilation as opposed to co-articulation, for her, assimilation and co-articulation are not the same phenomena. One is grammar, so in particular, assimilation is in the grammar, and the other is the result of what will happen when units of AP, of an AP nature, are combined. So in the view by Carol Fowler, we maintain a place for pure phonetics, even when the phonology embraces in that view is an AP phonology. So this is an example of an approach from AP, which is arguing for a more clear-cut distinction between the grammar and the phonetics than an approach which derives from optimality theory. So as you can see, issues can be subtle, but much remains unresolved. But of course, we also have a very good basis for starting to ask these deep questions. I will now turn to the final part of the talk, which is on phase-space reconstruction, and I will present some new results there. So we will start with the fundamental assumption that the co-representational units are specified by fixed point dynamics. And I will reconstruct the phase space of phonemic sequences and study its topology in terms of number and type of attractors. And I will show that as rate is increased, phase space topology, in other words, the qualitative organization in the vocal tract, is related to the phonemic representation in non-trivial ways. In other words, there is no fixed isomorphism between a spoken utterance and its dynamical organization. So I think the picture is very clear for most people here when we specify gestures in terms of the task dynamics model. We have a fixed point. This is the equilibrium point, and this is a point attractor. So the task that we're using here is a repeated sequence of ka. So what we expect is to find two units. So one unit is to bring the tongue body in contact with the palate. This is for the consonant K. And the other is to bring the tongue body at some configuration away from the palate, and this is for the vowel A. In task space, we're going to use tongue body constriction degree by computing distance to the palate, as I will talk about in the next slide. So therefore, the expectation is that we find two fixed points, two attractors at minimal and at maximal TBCD. So remember that task dynamics does not model articulate or locations in model task variables. And we have to use, if we want to do our job right, therefore, we have to use palette relative coordinates. And so we do by following work by Neufeld and Pascal van Lieshout, work by Beckman and her collaborators. So we compute tongue body constriction degree as the distance to the palate by reconstructing the palate of our specific participants. So we can now plot our data. This is a time series representation. These are the phase trajectories, which of course look like cycles because the task is to produce open and close, ka, ka, ka. This is a repetitive speech task. TI is the code for the subject as opposed to FK, and 210 is the BPM, is the beats per minute. This is a relatively slow rate. This is a faster rate. When you look in the phase space trajectories, there's no qualitative distinction between the, let's say, the different rates of the different participants. But as I will argue in the next slide, different attractor topologies are involved. So you cannot make inference about, for example, the presence of limit cycles by just using phase trajectories. I put some, I would like to make that clear because in the past, people have used phase trajectories that are like cycles to hint or to conjecture at the presence of limit cycles in speech. So we need to do a rigorous analysis of the phase space and its attractor landscape. So what is the phase space? Is the set of all states of displacement and velocity here. And attractors or equilibria are characteristic states in the space which attract nearby trajectories, and as a result of that, they accumulate probability mass. So here is the phase space probability density of our data, and this reveals the existence and type of two types of attractors. One attractor is a fixed point attractor, which is a localized point-like region of high density. So here is what we expected to find, and this is indeed what we find. However, there is also a different type of attractor. There's a periodic attractor, which is a closed ring-like structures of high density. Let me lump across the 5 speakers so you can get more a qualitative feel of what's going on. We actually find 3 distinct topologies for a single phonological sequence. So at slow rates, we find 2 point attractors in agreement with AP and in agreement with standard linguistic theory, one for K, the other for A. In the modest rates, we find 1 point attractor only, so the A has actually disappeared, so the fixed points, the X0 for A has disappeared. And at the fastest rates, we find a periodic attractor. In other words, the phonemic sequence, ka, ka, so repeated ka, can have distinct dynamical organizations, 2, 1, and no fixed points. How does this relate to previous work? Perhaps you all know about the work by Stetson, which has been used as a basis by Tudor and Kelso to provide evidence for a change from ip, ip, ip to PPP by increasing rate. De Jong has published an elaboration of this result. Here, in our case, we're concerned with changes in the same utterance and no reordering of phonemes. In our case, the organization in the same utterance seems to change as a function of increasing rate. So looking forward, we hope to explore the typology of the regimes, how this relates to different lexical representations and different phonological sequences and different phenomena. This is the end. I'd like to thank you for listening. Thank you for your attention. And I very much hope you have a productive and enjoyable time in Asilomar.